said, my name is Keith Denardo. I'm a managing forester for the Eastern Connecticut Valley District here on Division State Parks Reclamation Land, DCR. We're standing in the wonderful Wendell State Forest. It's about 7,000 acres in the town of Wendell. More particularly, we're standing in a 25-acre red pine stand, or what was a red pine stand at one point. So this was a stand that was planted by the CCC back in the 30s. Over the course of time, my predecessors had done some management here. Back in 1990, they did some work. I'm not sure this specific regarding that sale or what was removed. And then again in 2008, they hit a little bit harder. When I got the reins in this position, there was about 70 square feet of basal area per acre here, about 20,000 board feet per acre as well. So the volumes are pretty good in terms of the red pine. It's like straight and tall. It was being threatened by red pine scale. You can see pretty much everything that wasn't cut is either dead or heading that direction. So the idea, we had a whole bunch of pre-existing regeneration, advanced regeneration. The idea was to take the top off before we lost the red pine. On both sides of the road, due to some restrictions around salamanders and buffers around a vernal pool that was discovered during the public process, we actually left 65% canopy cover of red pine on the north side of the road, whereas here we were allowed to remove all of it, even though we were still within the buffer. There just wasn't a political will at the time to push back on natural heritage recommendations pertaining to the protection of the salamanders on that side of the road. So we left a lot of those trees to die standing. These trees here along the road, that's a 100-foot aesthetic buffer that's required in Massachusetts on scenic roads that are designated scenic roads. There's currently plans in the works within the agency to remove trees within striking distance of the public right-of-way. That'll be at a cost to the Commonwealth. There was talk about doing it at that time, but there was a lot of contention around this one. With folks in Wendell, some of the town government folks got involved as well. This was a fairly contentious one.
Yeah.
It started in the early process of our public process. We started getting some feedback on some negative feedback pertaining to the proposed management, and it continued right through active management. So we had a local company cut this one. They started in 2018. We started on this side. They actually left that year to chase oak that was killed by spongy moth just across town. They came back in 2019, and it really gave individuals in town and the area time to organize, and we had protests out here every single day that the harvest was going on, and I think ultimately ended up in 30 to 40 arrests and a couple of lawsuits. So, what we did here in this red pine is the idea with the overstore removal, protect as much regeneration as possible. I limited it to the equipment mix to cut to length and border only. So we did not pull any poles out of here. There was no whole tree harvesting or skidding of whole trees. That was a little bit contentious with the bidders because the money in red pine is in the poles. So economics wasn't really our driving force on this one in regards to generating return on the product. But I think they did a wonderful job protecting the regeneration. They work all in and around here. You can see stumps all mixed in, and they really did a great job. And that's pretty much what we got going on at this site at this time.
How many acres?
The 25 total, including the other side of the road. This is about 16, 17.
A plantation.
Plantation, right? Yep.
Ellie and Bob, thoughts?
Yeah, I lost a little fuzzy part on my microphone, so hopefully it sounds okay. So it's in the woods somewhere. I think I'm getting feedback from Bob. I was going to say, from a carbon perspective, sort of the ideal situation, right? Having this declining pine plantation with potential for really catastrophic losses in that carbon stock with those trees going down, but having this advanced regeneration, sort of, you can imagine the graph of this, right? Of not totally tanking in carbon because you have this really robust and quite diverse advanced regeneration coming in, and so you don't have this you don't suffer from these really large carbon losses that you might have without some active management here. So I think that looks, from a carbon standpoint, this is really ideal.
Yeah, it's one of those ones where you're out of options, really. Although you could make it worse by not protecting all the advanced regeneration, right? The next forest is already on the ground, partly, I'm sure, because it's been thinned by your predecessors, right? I mean, that wouldn't have come in stem exclusion if it had been 200 square feet of thickety red pine. It is a little too bad you couldn't have figured out a way to cut the poles, because that would have been more money.
Yeah, right.
But, that's politics. Is this a outwash soil? Does the pine belong here? Is this a nice deep till? What is it? What's the soil?
I think it's more of an outwash.
Okay.
It's more geared towards pine. There is some oak. You can see they're kind of, a lot of lower branches.
There's a black oak.
Yeah.
Yeah, I lost my eye for the red and black. Okay, maybe I haven't. So you want white pine, probably, right? White pine and some of the lower side oaks, I guess.
Yeah, the white pine had one of the higher site indexes for species listed.
Yeah.
And it's, it has done well. You can see some of the, can't see it from here, but, when we were selecting our retention trees, we were going heavy for the white pines.
Yeah.
Or anything that was native that snuck in through the red pines. But, for the most part, we got reds.
What is the political situation now?
Currently we are in a moratorium for cutting wood on state lands. All state lands, including Fish and Wildlife and Watershed. We did have the ability to run through contracts that were previously sold. We're going through the process. That's all I can really say about that. There's a lot of gears turning at higher levels, and once they tell me what to do, I'll go do it.
I guess I meant locally.
Locally here. So we did get a lot of the protesters that were coming out here were, there were a handful of folks from town. A lot of them were from out of town and commuting in. Any given day we'd have 25 to 30 folks out here holding signs and standing in front of trucks and hugging trees and chained themselves to the logging equipment. But things have settled down. Now the trees aren't getting cut. A lot of the folks, a lot of the locals, when I talk to them or say, hey, that doesn't represent our community, and there were a lot of, it was just a minor portion of the population here in town. We did get a formal apology from the town select board regarding some issues we had with them, and I'd do another timber sale here in Wendell if it came down to it.
Oh, yeah.
Yeah, so across the street, the north side of Montague Road, during the public process, a gentleman had identified and got certified a vernal pool. That came with that is some conservation management practices, and Natural Heritage Endangered Species Program wanted us to maintain at least 65% canopy cover within a certain distance of the edge of the vernal pool. We had a lot of conversations about it, and we did just that on the other side of the paved road. So you can see everything that was there. It came out to about 90 square feet of base layer per acre we tried to retain, and it's predominantly dead. And there has been talk about contracting at the cost of the Commonwealth, like I said, doing some hazard mitigation along the state forest road as well as the public right of way. So here we're standing, it's part of the same project, but this is an 80-acre oak stand, predominantly red oak. Pre-harvest conditions, we're about 120 base layer per acre. Across all species, oak was definitely the dominant one in here. Through natural succession of revegetation of an old pasture is what I suspect. I had some old 1927 forest stand maps that showed this as a 2 to 4 inch diameter mix of hardwoods, oak, black oak, red oak, paper birch, etc. And as we walked through here, as I walked through here, it was pretty evident that normal succession had run its course. Paper birch is starting to fall out. I estimated at the time at about 100 years. We did do some increment boring on some of the overstory oaks, and it was right around there, 100, 110, somewhere in there. So the idea with the silviculture on this one was to regenerate about 20% of the total acres using third-acre openings. We're not standing in one here, but there is a third-acre opening right there on the edge of that white pine right on the other side of it. The way I set that up was I used GIS to create a distribution of random points. Came out in the field to field check them. If I felt it was appropriate based on the conditions of the ground, the regeneration present, overstory conditions were there for it, we'd mark it out in the field. And then in between the gaps, we did a thinning. The idea with that thinning was to maintain a minimum basal area of about 60 square feet per acre. We definitely left it higher in some spots. And focusing on the removal of less low vigor, high-risk trees, the removal of those ones. This was the site where we got a lot of the contention. Not too many people cared too much about the red pine. They were pretty much standing dead trees already. The oak did generate quite a bit of interest. I had no records of any forest management occurring in this stand from 1927 to the present, although there were some handshake agreements at some point with local firewood producers, and I did see a handful of stumps out here. But no paper records or paper trails of sales that have occurred. This was one of the first since its natural regeneration.
Are there more deer here where we saw?
Yeah, yes.
It looks a little heavier.
There's a significant deer population, and I saw a handful of moose while I was out here monitoring the timber sale, and they've been around, hanging around, munching on the regen since. So there is a little bit of more predation in terms of herbivory on the site.
Well, I think you've left all the right big seed-bearing oaks, right, for your objective. You know what I'm going to say about the gap already, so I won't repeat myself. I'd have left maybe one. In the third acre, one big white oak out in the middle there would have made a positive difference, both for shade and seed source. Just to clarify what I've been saying is that there's not one magic. Heavy cutting, light cutting. You need to do both. You need the initial shelterwood entry should be pretty light, in fact, very light to get the oak established, and then when the oak needs light, then you come back and make the heavy removal. One magic cut's not going to do it. Starting with a heavy cut with no advanced regeneration, even a third acre, half of that's going to be sunlit, is probably not going to regenerate well to oak. Birch will probably like that, right? And red maple maybe. I don't know. Again, I'll just say this. I spent my whole career teaching about gap size and light dynamics and all that stuff, the bigger the gap. I finally, when I started managing my own land more intensively, I said, that's just silly. You make the gap as big as the forest, the stand is telling you to make it. If it needs to be 2 acres of fairly heavy removal, do that. But leave the retention in the gap to create the light environment you need. Don't rely on edges. Unless you really want it, like a big diversity in the gap. But if you want oak, you would, you could make this, 2 acre gap of low, with 20 to 30% relative density retention, and you'd have exactly what you wanted for that oak, right? Once it was established. But before that, I think that's too heavy because you're going to get, certainly in the southern Appalachians, their whole regime, and right up into Pennsylvania, and I think it shifts somewhere in Connecticut, so this may not be applicable, but it's important to think about it this way. Their shelterwood regime for oak is to kill the mid-story and not cut a single tree from the canopy. Not a single tree. So there's no establishment cutting. You have the 3 steps in shelterwood: preparatory, establishment, and removal. Right? They do the preparatory steps. They kill all the mid-story, just like a beech, anything. Hemlock here would be in the way if you wanted to get rid of the oak. And then you wait. And then the oak comes in. If you even do like a 40% removal, all this other stuff just comes in everywhere in the shelter. But like a 30 or 40% removal is a disaster because everything comes in, outcompetes the oak doesn't establish, it dies out. Then you wait. Once that oak is up to here and it's well established, then off comes the overstory down to a fairly low retention. So it's this odd shelterwood system where there's no establishment cutting. The establishment cutting comes from cutting the mid-story. I've come to the conclusion in the Maine and the Acadian region, sugar maples like that. That's the one reason we get all fouled up with managing beech all wrong. And I'm writing about that right now. That's a whole other thing. To get sugar maple, you got to do the same thing. Let the sugar maple advanced growth build up for 20 years, right? And to do that, all you need to do is cut out the mid-story beech, nothing else, right? You start making big openings of beech suckers, then you got to spray it. I mean, you probably have to kill it anyway. Anyway, so there's a lot of parallels there of light cutting, vary the cutting intensity temporarily, right? Light to get the advanced growth established, and then give it, based on its shade tolerance, give it whatever light it needs once it's there to be competitive. Ken was saying, okay, well, the black birch is starting to overtop it at age 20, then give it more light, right? It's there. Then that's a sign, that's what the forest is telling you. But immediately heavy cutting, where you're going down, to 30, 20%, even on a scale like that, is probably not going to regenerate much, but a bunch of light-seeded species along the shaded edge. Advanced growth is critical for all this stuff. So, that's enough.
I just have one question, actually, for you both. We haven't really talked about invasives, and that can inhibit sort of long-term carbon goals, certainly regeneration success. What's the invasive plant pressure around here on some of these lands?
Right here on this site, it really wasn't that bad. I did see an off Japanese barberry in a wetland. Everything I saw, I hand pulled it, but there hasn't been, there wasn't a large population here to begin with. We do have a fairly rigorous process of ensuring equipment is cleaned prior to moving on site to try to prevent spread from other locations. And then, follow-up regeneration inventory just to monitor and prescribe additional management if needed. This site, at the onset of actual management, I didn't see invasives as being a threat. Like I said, an offhanded, Japanese barberry, maybe a buckthorn, but it wasn't a large enough population where I thought it'd be a problem. I mean, eventually, yes, we'll probably have to do something, but at this point, I'm not too worried about it.
Excuse me. This is just a comment to back up what Bob just said. You go to a lot of places in Connecticut, and there are oak seedlings on the ground. You lay on the ground and you look up, and what you see is ironwood leaves, you see black birch leaves, you see red maple leaves, you see beech leaves. You don't see the upper canopy at all. And so we're working on some trials where we do just that, and we drop everything on the ground. And just like in the slide you saw this morning, or the video you saw this morning, we're leaving it all on the ground as a big carpet. And the idea is we won't stop the deer completely, but we'll slow them down. They'll go someplace else to eat rather than get their feet tangled up in that mess. And that'll buy us maybe 4 or 5 years. And we're hoping we can get some of that oak to recruit, to get to shoulder high, where then it will be time to maybe start to release it with some work in the upper canopy. That's all.
Thank you, Tom. Right on.
Knowing what we know about defoliators, aren't you just causing like a big problem down the road if you're just growing oak like this density together?
It wasn't me. It was our colleague Frank Servo said, at least in our part of the world, if you manage for oak, you'll still get birch and beech and maple. All right. If you don't manage for oak, then all you're going to get is birch and beech and maple.
Yeah. I mean, these forests had way more chestnut, right?
Yeah.
That should be a long-term goal. Bring that down. Does the spongy moth feed on chestnut? It's oak, but I don't think so. It probably does. We don't even know.
It will eventually.
Yeah.
If it runs out of oak leaves,
Yeah.
you want something else.
Yeah, I'll comment to the defoliator part of it though too. Is that this active management though allows these trees to build up more reserves. There's less competition for these trees, so if they do need to refoliate or if there's other pressures on them, they have the reserves in place to refoliate and kind of get through that initial defoliation. The other part of it though too, I know with say forest tent caterpillar and spongy moth, is that they have a much harder time to move from tree to tree if there are well spaced and there's not a continuous canopy that's going across here. So actually maybe not where we're standing right here, but a more open canopy that allows some spacing in between the oaks. It makes it much more difficult for those defoliators to move from tree to tree.
Question over here.
More a comment, but about the defoliators. Having been through the early 1980 massive defoliation, shagbark hickory, and you guys have bitternut, it looks like, is a very good tree to have mixed in your stands because gypsy moth will stay away from that, even when they've eaten everything else. They also really don't like red maple, and so those are two species that are great to have as a mix. Pretty much everything else they'll take if they're hungry enough.
Thanks, Charlie. Steve, I wonder if we don't have our wildlife expert here. David King will present tomorrow. I know you wanted to share a few thoughts about wildlife today.
Yeah, sure. Well, I think at that last site was our previous stop, not the last site, but I really like those sites. Bob touched on it a little bit in terms of the work that came out of Yale looking at early successional birds, and while at the same time having an overstory. That plantation site was a great example of what we would see in there. We would see towhees in there. We would see prairie warblers, all kind of obligates to shrubby habitat, early successional work. They're definitely in that patch cut that's over there. But what we have in addition in the matrix that hasn't been opened up, there's rose-breasted grosbeaks coming in there. There's orioles in there, and in some cases you may even see in that taller regeneration ovenbirds starting to come back and make a living in that setting. So you think about that diversity that's kept by having that partial overstory or that continuous canopy. That just adds much more diversity in terms of songbirds and other critters that you would have there. Than you would have just in that, just that big 5-acre patch. Bob's pictures of, you had that, I think it was one of your last slides where you had the open patch and you had the patch with retention. That's a good example of that as well, is that both of those, that would serve as early successional habitat for those birds, but that the one with retention just provides so much more opportunity that's there. So I'll just say with a caveat though, to Tom's point on the second stop, the second visit in that permanent CFI plot, is that you're going to have to enter into those sites more often to keep that shrubby, to keep that regeneration going, because that shade will start to kind of creep in as the canopies expand and get in there. It takes work, right? But I would say that both of them have their role in the landscape, but I think there's a great opportunity to get kind of your cake and eat it too with that early successional habitat underneath with a well-tended stand up above.
One of the things that I've been this is to some degree semantics, but it's forest ecology. We talk about early successional habitat and young forest of mid to late successional species as if they're the same thing. They're completely different, right? When I talk about ES habitat, these are the fields. These are treeless places that we're going to keep treeless in the forest. And maybe if we had, early forest fire, some wildfire or something, you would have truly early successional species. But that was very rare. Those come in the fields and the landings and places where the trees are scraped away. And so sometimes when I talk about, you don't like any, early successional habitat, I got nothing against it. Have whatever we want and just keep it in the same place. And they think, well, where are we going to have our young trees? Well, that's the young forest part. We need young stands of oak that are this tall, right? That is not early successional habitat, really. That's young forest of later successional species, and that's something different to the critters that live in it, right? And maybe some invertebrates don't care, but I think there's other things like the ground. There's just all kinds of differences to that ecologically, mainly in a management sense, because that's going to grow out of that, right? The other thing is if we're going to maintain the true ES habitat, that's really expensive, right? You got to go in there with the brontosaurus, you got to mow it, you got to do all this stuff. And remember, that's not natural. That's the designer landscape of the 1930s that people want to keep around. That was, the natural early successional habitat was 1 or 2% of this forest. So there's a reason these species were rare and are rare that depend on those early successional habitats. I think up in farther north, the really early successional habitat, there was some fire, right? Real fire. It mostly came from beaver flowages were flooded and then abandoned by beavers. And then you'd have mud, right? And you'd have these 5-acre beaver ponds would come in and just lush with all kinds of species you don't see anywhere else. That's still going on. Things like that. That's ES habitat. That's different than young forest of late successional species. The main lynx issue is that, all this clear cutting, right, brought on the lynx. The true clear cutting, there's no lynx where there was true clear cutting done. None. Those regenerate into crappy hardwood stands, and that's not lynx habitat. The lynx habitat is young forest of late successional softwood species, right? 25-year-old stands of fir. And that's a big, huge difference silviculturally, ecologically, and everything else. So we should be a little more clear about how we use these terms silviculturally and ecologically.
All right, so here we are at CFI plot 1262 in Wendell State Forest. So we had a review of the handout last time. I'm not going to go into details on the organization. The presentation's exactly the same. This, again, is one of our, it was installed in the original group of CFI plots back in 1960. It was most recently measured in 2020, but the data that are on the chart are actually from 2011. As I mentioned, we're in the process now of starting to transition to annual measurements on our CFI plots. So once we get halfway through this cycle, we'll start to have a more robust sample size to be able to generate estimates that we can reliably work with. So one of the reasons why I thought this would be an interesting plot to come to is that this plot right here is at the 96th percentile of live tree greater than 5 inches dBH of above and below ground live tree carbon. Within 52.7 foot radius here, we've got an estimated 240.5 metric tons of carbon dioxide equivalent per acre. If we start to compare that to some other estimates, this plot is a little bit closer than the other one. So on the Jenkins estimate, it has 259 metric tons of carbon dioxide equivalent per acre, and we're in the same ecological subsection as the last plot. So the C bar, the carbon to basal area ratio, is the same. So we have about, 225 square feet of basal area per acre here. And using that C bar, that works out to 253.1 metric tons of carbon dioxide equivalent per acre. So again, what we're seeing here, as far as the estimates of carbon relative to the last plot, is these trees are a little bit more intact. On the last plot, some of the trees had broken tops. They were a little bit shorter in stature. These trees are a little bit, these trees are more intact. Now, since that last measurement, we have had some blowdowns and the canopy has started to break up a little bit there. It'll be interesting to come back and see what that looks like. Are the trees going to fill in, or is that going to start to be a point of entry for trees to sway and start to full down a little bit more? A couple other things that might be worth pointing out is that the stand density index for this plot is again, it depends a little bit on what, how you want to calculate that, but is 350 to 465. When we start looking at our CFI plots across the state, we find that mortality generally, kind of remains relatively low and starts to plateau when we get to a stand density index of around 200. And then from 200 up until 400, 450, it remains relatively constant. It doesn't increase. Much above that, we do start to see increasing natural mortality. And I think we talked a little bit about at the last site, when stands are very dense, they're competing for growing resources. They don't have the ability to expand their crowns, to put photosynthate into root starch reserves to help be resilient against stressors and reserves. A couple other things that might be interesting to point out is that in terms of down woody material, we don't really have a lot at this plot if you ignore the recent disturbance right over there. So prior to that, it was at the 17.8 percentile with only about 1.5 metric tons of carbon dioxide equivalent in down woody material. Again, most of the carbon is in pine here. About 3/4 of the overstory is in white pine biomass with a little bit in oak and maple and black cherry. I think, and the only other thing that might be worth pointing out is that, so it's about 125 years old. We had cored a tree at the last visit in 2020, so at that point in time we were getting 125 years at breast height. This plot did receive a light thinning, a very light pulpwood thinning in about 1991, but in addition to being very high in terms of stocking, it's also very high in terms of growth. It's at about the 99th percentile for survivor growth and 99th percentile for net growth. So again, this is one of those rare rare plots where, at least right now, we haven't made too many sacrifices, right? We have high stocking and it's continuing to grow. But for how much longer? I'm not trying to spell doom and gloom or anything, but I turn it over to Bob. And are there any interventions that we might talk about for, for maintaining resiliency here? Or Allie, do you have any thoughts?
Clearly, you wouldn't want it to get to this stage, right? 225. I think mortality actually would start setting in at about 60% relative density, right? That's 300 SDI. So if it's way above that, but not an. So it's a old field stand, probably 1890s. Very light thinning. That is high. That's the way to grow lots of carbon. That's the Germans figured this out a long time ago. You plant spruce every 8 feet and just let them thin from below for 100 years. You get amazing yields, although then you end up with this completely unstable, non-sustainable structure, right? So this is where, because you cannot keep thinning, we all know you can't keep thinning forever because of wind farm decisions. So, so this is where gaps, even more so, would be gaps about maybe even as much as a tree height. What are these trees? Trees are up 85, 90 feet, more than that maybe. Whatever, some gap about that size, which would be what, fifth acre, half acre? Not that big, about a third acre, just like we saw. On some percentage of the stand, and you figure that percentage of the stand out based on how many entries you're going to make and how far apart they are and how long it's going to take you. And you want the matrix to last until that's over. Pine, being long lived, could last a long time here, especially if you did it in small gaps, and then, thin them. You can thin the matrix in these things, but you have to thin it lightly from below. You can't go making big canopy gaps, right? And that would also be a carbon loser. So pick out the high risk growing stock, remove it, try to keep the overall removal below like 30% and something like this that's that unstable, and do that on about a 20-year cycle. That would be my optimum carbon strategy for this from now on. It would have probably thinned it more heavily earlier to keep the leaf area and fewer trees, right? I think we all know that. The sooner you enter, the more likely you're going to have something that's stable and lasting. But,
when we came out to this site, I think maybe for a lot of you will recognize this is a very common occurrence across our region, especially on private lands. I know a lot of private landowners have conditions like this, and so this is a good one to do the exercise in and thinking about some of these trade-offs. And what would you do, right? A lot of these trees have multiple stems, and I would be actually interested to know how much that's factoring in, multiple liters, factoring into some of the carbon storage component, but thinking about how much value do they have too, right? That trade-off between coming in and doing some work and extracting some of these trees. A lot of them have weevil damage. But yeah, certainly this is a interesting site. We were Steve and I, when we came here and heard from Bill about the level of carbon storage and the level of sequestration, we were kind of shocked. But this is why we want to do this here, to think about carbon a little bit differently, to be able to visualize this stand being sort of the leader in the state for both of those metrics is pretty interesting. So is this stable, resilient carbon, right? If a disturbance comes through here, what is going on in the understory? Are there smaller trees to take over if we lose some of these overstory trees? Those are sort of good questions to think about the longevity of the carbon benefit at the site.
It doesn't surprise me that the pine would stand out. I spent a lot of my career studying the concept of growth efficiency, which is the amount of stem wood that gets produced per unit of leaf area, right? White pine is the most growth efficient species in New England. It photosynthesizes across a broad spectrum of light. From March to November at least, as long as it's above freezing. And it just is incredibly good at turning sunlight into stem wood. Now, the other side of that is it's not very carbon dense because it's low, the specific gravity is low, but it makes up for that by the high volume. If you look at growth efficiency of hardwoods, it's going to be more similar, because like oak and beech and things are very dense, right? So the same leaf area. The leaf area index here is way beyond the peak, right? And it's now gone into understory reinitiation. That the reason that the leaf area patterns are the way they are, the reason that productivity peaks fairly early, sequestration, is because when trees, dense stands of trees grow up, all the branches intersect, right? And then in the wind, they don't knock the leaves off of each other. So the canopy is completely enmeshed. So that is the highest leaf area. Then, of course, the base of the crown is light extinction. Things can't exist below that. That keeps growing up. That's a non-sustainable structure in an even age stand. Until the trees get about 60 feet, twice that tall, and they start to sway, and then you start seeing what Dave Smith used to call gaposis between the crowns, right? You look up in these stands, they don't touch, right? And that's because the branches are swaying differentially. And the taller the trees get, the more that's true. And that's been studied now for, there's always this growth decline with age. And it's not some inherent biological inefficiency with age, at least until very old. It's just the fact that physically, even age canopies can't support the same leaf area when they get tall because of differential swaying. It's just that simple, right? So eventually they lose their grip, they start growing slower, light starts to leak through, so that's telling us it's, understory reinitiate is happening. That's the time, silviculturally, we need to start to replace the leaf area up there, which we can't anymore. No amount of thinning will bring that back. It will when it's young, right? When you thin that same stand when it's young, that will come back. Not when it's this tall. We have to replace the leaf area up there with down here, so it's past time to start making some shaded gaps with a light retention in it for white pine. And, fortunately the deer don't eat it much, right? At least where I am. They might nip it, but it's not like hardwood. So we should be able to regenerate pine in mixture. And I would want to keep the hardwoods. I would retain all the hardwoods on this plot, right? I wouldn't cut one of them in any kind of, because just for the diversity, that will give you more wind permanence. There's just every reason to keep those things. So that's the biology behind what we're doing here, right? It's time to leaf area down here. Not all of it, though, right? That would be too abrupt.
So I'm just putting this out there as we're thinking in managing forests with carbon in mind, and we're using logging equipment to do the logging to accomplish that. We all know that you can have a range of impacts on the soil from almost zero if it's very frozen to 12, 18-inch deep ruts with 85,000-pound machines moving around. So at what point on the spectrum would we be saying, oh, the silviculture might be helpful, but because of the logging that we need to do, it's actually a negative? Like, where's the cutoff?
The cutoff is when it rains 3 days in a row. The machines go sit at the landing until it dries out. I know it's easy for me to say that, right? And as long as you have machines that can do that. That's why old skidders were nice, right? You guys just go home and work in the garage or something. Now they've got this huge capital investment, right? They need to work. So, and with the warming climates, these horrendous large rainstorms we're getting we never used to get, it's just a mess. I'm glad I don't have to make my living as an operations forester this summer in New England. It was just awful, unless you had a bunch of gravel or something to work on. So I think you have to manage. It's like we've always had, Mike. We have always had to manage logging to accomplish silviculture. That's always been true when we're cutting commercial trees, and I think that's what. I don't know. On the other hand, forwarders especially now are too big. If you had forwarders about 2/3 of half the size that they carry now, that 16-ton buffalo that we use on our land is way too big. The harvesting isn't the problem here. It's always it's the yarding to the roadside. It's the forwarding, or even worse, grapple skidding in horrible conditions. So, that's why we have the BMPs. We should follow the BMPs, right, and all of that. But what you're saying is that even if you do a good job, there's still these big machines in the woods, and they're not doing us any good. Compaction.
Well, okay. Just, we've always been concerned about compaction and rutting, considering these to be a negative thing that we try to avoid. And it's getting harder to avoid it as we have less frozen time in the winter, and the machines are so much bigger than they've been. So, but when you're adding carbon to the equation and you're thinking about, we're trying to have as positive a carbon impact as possible, or at least as minimally negative one as possible, how much more is there even more importance that we need to give to this type of consideration?
You're worried about loss of carbon, soil carbon.
Not only not only loss of carbon, but loss of the capacity of the soil to continue to store more carbon, because you've damaged mycorrhizal networks, you've changed the flow of water, you've changed the soil from what it was to something that's different.
Yeah, I think it's something we all should, it's something we need to pay more attention to. So that's a great question. I would say, anytime where you're seeing physical deep impacts of equipment into soil, you're causing some sort of damage, right? So the deeper that is and the more surface in the woods that covers, the more impacts you're having. So things like, if you can, permanent roads, limiting road that you have, limiting trafficked areas, right? Using the lightest equipment or the equipment that has the smallest impact possible, but it's going to be really challenging for loggers to be nimble, right? Responding to conditions as they come. So yes, frozen conditions, great. Dry conditions, also pretty good. Soil is much more likely to be compacted when it's wet. And so that's something, to staying off wet soils. And so that might be things like on a parcel, there might be areas that stay drier, right? Saving those areas, going into the wet sites when it's dry, right? And saving the drier areas in case there's wet conditions and those soils are well drained, right? So really paying attention to what kind of soil you have, how well it drains is really important. And then there are things that we can do with equipment, right? So using temporary bridges to avoid wet areas. Certainly folks are doing things like corduroy, tops and limbs on the site, on the traveled surface to limit their impact. And it is costly, it's time, intensive, but it really does help protect that soil. We know it's not just, right, the carbon, as you mentioned, all the organisms. There's a cool fact that more than 50% of life on Earth lives in the soil, right? And so we don't know a lot of what's going on there, but that nutrient cycling, water retention, all that important stuff that happens. So I think, for the general forest health, regardless of carbon, that is really critical. So yeah, it's sort of mitigating. It's really hard to add carbon back to the soil. It happens very, very, very slowly, but it's quick to lose it from the soil. And so keeping that in mind of mitigating the impacts when you see them is going to be more effective than trying to fix it after it happens.
When I watched Allie's webinar on this, it was last May, whenever, she's talking about hardening trails, right? This practice of winding the brush right to the wet holes, right? And then pounding it down in there, pass after pass, right? That's in that weird train. This is good, right? Because that keeps us from rutting the mineral soil. Of course, usually it happens after the rut's formed, but whatever. Well, and then she says, if you do that even in a wetland ecosystem, that never dries out. Guess what happens? You get methane emissions. You don't get just regular decomposition. You get anaerobic decomposition. And of course, methane, 30 times worse? And so there, yet another practice, that's like, maybe we need to do something different here, So again, stay out of the wet. I mean, obviously, just as she said, stay out of the wet.